when you have stored in memory a spatial or visual property, so it's not just spatial like triangles and things like that, but it can be color. But it's not stored explicitly. It was something you just noticed. You didn't think about it. You'll reconstruct the actual visual pattern. It's sort of like, by analogy, if you have on a videotape, which is not spatial, that's just magnetic pulses, information, you may need to play it and put a picture on the screen in order to be able to recover what's there. So in fact, it turns out the visual memory areas of the brain have projections that go backwards to these areas that are topographically mapped. And we know the visual memories seem to be stored as representations in these columns, not spatial. If I ask you something you hadn't thought about before, you may need to sort of play it backwards and reconstruct the spatial pattern, which you then look at again, as it were. Now try this. What shape are a cat's ears?
What shape?
Cat, chat. La chat.
It's a triangle.
Oh, yeah. Okay. What shape are they? You were right.
They are triangle.
Thank you. One more time. What shape are a cat's ears?
Triangle.
Thank you. Just one more to make sure. What shape are a cat's ears?
Triangle.
Okay. The first time that you answered that, your eyes moved to the side, and you were rather slow. You probably visualized the cat's head, and you never really thought about the shape of its ears before, so you mentally reprocessed the ears. But by the third time I asked you, you now had stored that information in an explicit form. You remembered triangular. You didn't need the image anymore. Your eyes weren't moving, and you were much faster. In fact, young children use imagery more than adults, and are slower than adults. And as they get older, you see them using imagery less and getting faster. So imagery is relatively slow, but it's very rich. It has embedded in it lots of information that you may not even be aware you know.